Right, some more experiments with this setup I showed about a week ago. I started up, there we go, this is this one running. You'll notice that all that's connected is a clip lead because on the other end of this clip lead and going into this circuit, that light is on. And what this is some form of replication of Dr. Stiffler's, one of his latest videos, where he's got a coil. I've got 100 turns on each side, it's joined at the bottom. The power goes in to that bottom join, and then the two top ones come out and they go to a bridge rectifier. I've only got 4 1N 4148s on this because there's no way it's kicking out 200 volts. But the 1 watt LED at the back there is on okay. It's it's certainly transferring some power to it. I've also found out that a clip lead connected to the back face at the back of the heatsink of it improves the running. If I disconnect, you'll see that it does dim. So there we are, that's that experiment. But that's my version really of the circuit that Dr. Stiffler showed. For those that haven't seen my previous video on this subject, what it is 2 matched Slayer exciters, and they look a bit like the Dr. Stiffler SECs, and I want to be edging towards his kind of experiment by using a Slayer exciter setup with 2 that are exactly the same. So here is the circuit itself. It's just a regular G Brewers Slayer exciter, and all I've added is on one of them at the moment is the addition of a picofarad tuning capacitor from the base to the collector of the transistor, and the 2 transistors in this case are C3198s. So everything's the same except that one of them has got this little tuning capacitor on it, and the power is a 1.5 volt AAA. Quite a dead one really, and that's the idea, is to use the dead ones up that I've been using in flashlights and what have you. Right, the setup has now changed, and so what the diagram looks like now is there's a 10 UF capacitor across the input, and that allows to show the next effects I will be doing. On the pickup side we've got a coil, this time of 24 turns of a much tougher gauge, it's about 26 AWG, then a variable capacitor which actually comes from a radio, I think it's 0 to 512 PF, and then the 2 diodes, so we get a plus and a minus. So let's start this up. Okay, and what you'll see is the flashing effect, and what I'm doing here is something for, and I'll get your name wrong, it's Deslomeslager, sorry if I got it wrong, and I will have done, but it suggested putting a rechargeable battery in line with this LED that's flashing. Now this is on an AV plug, so what you've got is the pickup circuit, which is exactly the same as the first one, but it's tuned with that variable capacitor. The clip lead there comes off the pigtail on the end of it, goes to the AV plug, which goes to this LED, and this is flashing at the moment. And then we've got this in the way, basically, this 1.2 volt battery with the heatsink there. And his idea was, can it actually get a charge from what's going on? Because what you've got is the plus leading through to the minus in a way. Unfortunately though, it doesn't seem to be working, at least in this way. There may be, I mean, with more current and voltage going through, I guess something may happen, but 0.551 is where it's been sat at really while I've been setting up and experimenting a bit. But so I don't know, jury's still out as they say, but it's not harming anything and it's going through the circuit. If I disconnect this meter then it still works. So yeah, this is very interesting. But anyway, so there's our gap there, and you can see that this one is running quite nicely. This one is flashing away, and that's because of the 10 UF capacitor that's charging and discharging as the voltage for the C3198 builds up, able to fire, and therefore that's what happens. And it also gives, of course, the flash at the same time of the LED on the AV plug. If I turn this, and I do apologise, I'm using this screwdriver, but if I manage to turn it, yeah, you'll see that it stops. Turn it back again and there we are, it's flashing actually faster. So that's better tuned up. Keep going to the left, oh, it's out again. So I'll bring it round to that fast flash, leave it alone. And there we are, that's about the optimum, but that allows a tuning on the receiving side. So I'm quite pleased to have found that, and it is actually a lot easier to find these little portable radio type of capacitors than it is perhaps to find those little ones there. So anyway, that's what I wanted to show, and as you can see it's still on 0.551. And here we are with the meter completely disconnected, and you can see that it does still work. This wire here, if I disconnect from the LED, you can see that it actually does stop. The rest is still running quite nicely, and it does stop, so it is properly running through it and connected. There we go. But unfortunately it doesn't look like that it's going to charge like that, at least with this pulsing. But if things go on and I get the distances better and a bit better tuning, that kind of a thing, then you never know, and I'll keep trying with that method. But anyway, that's a bit of an update there of these two match circuits doing something different, and thanks for watching.